I am Furkan Kınlı from Özyeğin University. Now I'm going to present our paper titled Modeling the Lighting in Scenes as Style for Auto-White Balance Correction. This work has been jointly done by Doğa Yılmaz, Barış Özcan and Professor Furkan Karaç from Özyeğin University. Let's start with our motivation in this work. White balance correction is one of the earliest ISP operations applied to raw images, which normalizes the effect of different lighting conditions. Also in the literature, the concept of style can be interpreted in different ways. For example, age of person in face images, or painting style of an artist. We can state that any disruptive or modifying factors for the whole image can be modeled as a style factor. Starting from this statement, we assume single or multiple eliminations in the scene basically stands for the additional style information injected into the scene, so we can remove the effect of elimination by removing the style information. In our work, we have followed the prior work, which uses a learning mechanism for the weighting maps of the scenes composed of predefined set of white balance settings. To generate the final sRGB output image, we linearly combine the weighting maps with the images of different white balance settings. The overall architecture of the learning mechanism is illustrated in this figure. We adapt the style removal network as the learning mechanism, and it consists of an encoder-decoder structure employing adaptive feature normalization strategy to all layers in encoder. With the help of this strategy, any internal factor in the image can be modeled as an external style, which needs to be discarded or adjusted into another style. The main technical approach here is to align the feature statistics of images that are computed across special locations for obtaining the white balance corrected version. We suggest to check the paper for the further details about the architecture. For single eliminant scenarios, we compare the performance of our proposed strategy with the recent studies on Cube Plus dataset. We have conducted our experiments with different patch sizes, 64 and 128, and different sets of white balance settings. Following the literature, we have measured the performance with three different metrics, which are mean squared error, mean angular error, and color difference metric. All of our results outperform the other results over the most parts of all metrics. Particularly, the model trained with the patch size of 64 on white balance settings of TDS achieves the best performance among the other models with different settings. This figure introduces the comparison of the qualitative results of our white balance correction method and the recent methods. It demonstrates that our proposed method achieves competitive per pixel performance on white balance correction in sRGB space. We have conducted the same experiments on synthetic mixed eliminant evaluation set, and the overall results are reported in this table. According to these results, it's hard to pick a superior method over all methods, as depending on the metric. Our method performs better when evaluated on mean squared error, while achieving competitive results for mean angular error and color difference metrics when compared to the recent methods. Following table presents the results of different combinations of the post-processing methods applied. MS refers to using weighting maps in multiple scales. EAS refers to applying edge-aware smoothing to the weighting maps before blending. The results verify that these methods help to improve the quality of the weighting maps, so do the qualitative results. Lastly, night photography rendering is another challenging task which may contain different cases affected by multiple eliminants. To show the validity of our strategy in this task, we integrate our white balance correction method into the camera ISP for processing night images. This figure presents some examples of the rendered night images, and the results indicate that the pipeline including our method produces more natural and realistic images over a wide range of night images. This is the end of the presentation. Thank you for listening.